for our conclusion, there are 3 things that you need to be able to do. So the first thing you've got to be able to do is give a brief summary of your analysis. So looking back at that analysis, summarise what you found. Shape, centre, spread, shift, and inference. Then we need to decide if we can make the call or not. So our investigation question was, I wonder if there is a difference between the medians, and we need to decide, can we make that decision? Can we say that there is enough evidence that one median is bigger or smaller than the other median? The third thing we need to do is discuss sampling variability. So we're just going to look for now at making the call. I'm not even going to worry about doing the brief summary, because hopefully you should be able to do that by yourself now. Let's look at the making the call. So what we're trying to do is we're trying to decide, are our 2 distributions far enough apart? So are they close together? Are they far enough apart? And are they far enough apart for us to know that there is a significant difference, that definitely there is a difference? So, or do they have lots and lots of data values in common? So there's lots of overlap. So that means we don't have enough evidence to say that the groups are different. So picture A here, you can see the median of A and the median of B, and you can see there's not much data values that they have in common. Whereas for group B, the graph B here, these 2 distributions, you can see there's lots of overlap where there's lots of data values that both A and B have that are the same. So this would be an example where we don't have enough evidence because there's lots of data that's the same. Whereas in this part A, the A graph, we can see there's only a little bit of data that they have in common. Most of the values of one group is different from most of the values of the other group. And this is what we're trying to decide, is which of these situations do we have. So we want to look for, I've labelled these 2 groups, Group A and Group B, and I want to know, is Group B shifted further up the scale? Have I got enough evidence to prove that? So I'm going to take median of Group B, so there's the median, I've just added that on the diagram, and I'm going to subtract the median of Group A, okay? And when I do the median of Group B, take away the median of Group A, I'm going to end up with a positive number. If I try and do a specific example of this, if I take the median of Group B, so there's 1, 2, 3, so I say the median of Group B is about 3.2, take away the median of Group A, so this is 1, 2, there's the median of Group A is about 2, so 3.2, take away 2.2, I'm going to end up with a value of 1.2, which is a positive number. So I'm looking to see if I get a positive confidence interval, that means that median B, so the median of Group B, is bigger than the median of Group A. What about if it was the other way around? So if I called this first group B instead of A, and I called this one A instead of B. So I'm still going to do the same calculation. I'm going to say median B, take away median A. And so if I take median B, okay, so there's our median B, take away median A, this one here, which is a bigger number, a small number, take away a big number, I'm going to end up with a negative number. So let's be specific. So say the median of Group B was 2, 1, 2 on my scale. Take away the median of Group A, 3, so that's about 3.2. So I'm doing a median of 2, take away a median of 3.2. That's going to give me a negative answer, negative 1.2. So if I get a negative confidence interval, that tells me the median of Group B is smaller than the median of Group A. So a negative answer tells me the first group is has a smaller median, whereas in the previous one, when I got a positive answer, that's when the median of the Group B is bigger than the median of Group A. So we're looking, is it bigger, smaller, or the other possibility is, could the medians be approximately the same? So when I look at these groups here, okay, so the purple one and the blue one particularly, they've got the same median. So if I do median B, take away median A, I'm going to get an answer of 0. So this is one of the most important things, is we are looking for this value of 0. if I get a value of 0 in my confidence interval, that means the medians could be the same. That median B and median A could be exactly the same number. Because when I subtract two numbers and get a 0 answer, they must be the same size. So I can only make the call if the entire confidence interval is positive or negative. And that tells me I have enough evidence to say that those medians are different. But if 0 is inside that confidence interval, then that means the medians might be the same, and that means we do not have enough evidence to say that there is any difference between the two medians. So let's have a look at this particular one. So this is an example of batting averages. The key there is we want to focus on that confidence interval, and we want to look at that confidence interval, which I've just circled. So the confidence interval goes from negative 15.3 up to 45.5. So I want to know, is 0 inside that confidence interval? So I've dropped that confidence interval down to our scale along the bottom there, and 0 is right there. So is 0 in that confidence interval? Yes, it is. What does that mean? It means that the two groups could have the same median. So one of the groups could be bigger than the other because we're getting a negative answer, or it could be the opposite way around. We don't know for sure which way around it's going to be. So that means in terms of making the call, we cannot make the call. We do not have enough evidence to say that there is a difference between these two medians. So let's have a look at our confidence interval for our rugby players. So we've got our confidence intervals there down the bottom, and what we're looking for is 0 inside that confidence interval. And you'll notice, remember, the confidence interval goes from 16 to 23. On your scale, here's 0 all the way down there. Is that 0 inside this confidence interval? Absolutely not. Because the confidence interval is both positive, that tells us the weights of our forwards is bigger than the weights of our backs by between this much and this much kilos. But because 0 is not in the interval, we can be sure that there is definitely a difference between these two groups. That the weights of the forwards, we have enough evidence to say that they are bigger than the weights of forwards. And that's what we want to write for our achieved answer. So I can say I'm reasonably confident that back in the population of all rugby players, okay, which we're talking about the population we want to know about, and we can be confident that the forward's median weight is going to be more than the back's median weight. Merit, we want to be able to give our evidence. So we're saying, why can we make the call? And this is when we go and look at our confidence interval, and we can make the call because the confidence interval is between 16 and 23, and the entire confidence interval is positive. Okay, that's our justification. So the conclusion is based on our bootstrap confidence interval, which involves resampling from a sample of 135 rugby players. And I'm assuming my original sample was representative of all rugby players. So there is our merit justification, saying why we can or can't make that call. So excellence, I haven't written this one up because I want you to do it yourself. So for the confidence interval here, you need to refer back to your research. Compare your research at the beginning. Okay, does our conclusion agree or disagree with what you first predicted at the beginning?